First, let's go back to the basics. There are two forces that act on an object in water: the gravitational downward force and the buoyant upward force. First, let's talk about the buoyant force. The buoyant force is equal to the volume of the object underwater times the density of water. In other words, how much water would fit in the part of the object that's under the waterline. As an equation, it looks like this. Now let's talk about the gravitational force. Gravity is equal to the volume of the object times the density of the object. As an equation, it looks like this. However, usually when we talk about things floating, we only mention their densities. We can explain this using our formulas, which you can see me writing here. When an object is completely submerged, its buoyant force must be greater than the gravitational one for the object to float. In other words, the volume underwater times the density of water must be greater than the volume of the whole object times the density of the object. When the object is completely submerged, the underwater volume and volume of the whole object are equal, allowing us to cross them out. We are then left with the equation: if the density of water is greater than the density of the object will float. Inversely, if the density of water is less than the density of the object will sink. If the two are equal, the object will sit in the middle of the water. We can also use these two equations to talk about buoyancy in terms of weight. Remember, density equals mass divided by volume. Therefore, mass equals density times volume. Here on Earth, mass and weight are the same thing. So weight also equals density times volume. Now we know that buoyancy equals a volume times a density. Weight also equals a volume times a density. Therefore, weight equals buoyancy. From this, we know that the buoyant force is equal to the weight of the underwater volume of water. Now we also know that gravity equals a volume times the density. Weight also equals a volume times the density. Therefore, the two are equal. From this, we can understand that the gravitational force is equal to the weight of the object. Here are our new equations. The buoyant force is equal to the weight of the underwater volume of water. The gravity is equal to the weight of the object. We know that if buoyancy is greater than gravity, the object will float. So if the weight of the underwater volume of water is greater than the weight of the whole object, the object will float. So when a canoe is filled with water, it is very nearly submerged. We know that the buoyant force on this canoe is equal to the volume of the canoe under the water times the density of water. In other words, the upward force is equal to the weight of the amount of water that would fit in the part of the canoe below the waterline. Here we are actually filling the submerged volume with water, which should make the object have neutral buoyancy. However, the submerged volume is not completely water. It is also made up of a small amount of wood. Therefore, the weight is slightly less than an equal volume of completely water would weigh. Additionally, the average density is slightly less than that of water, allowing the canoe to float with only a small amount of the boat above the waterline.